Let's keep on going. So now we have a pilot of an airplane is flying 12,000 feet, sights a water tower. So he's flying this way at 12,000 feet. And here is the plane. And he sights or looks down and sees a water tower that looks like this, right? So that's the base of the water tower. So he sees the water tower. Angle of depression to the base of the tower. So depression is always from the horizontal opening down because you're depressed, you're down. So it opens like this. So now you'll see that we've created a right triangle. So here is a right triangle where this side is 12,000. I don't know if I said 1,200. Just go with it. 12,000. And you want to find what is the length of the line of sight. So line of sight means as I see it, when I look to the bottom of the tower, what is this distance d? So you're trying to relate an angle to its opposite from that angle, and this, since it's opposite of the right angle, it's going to be our hypotenuse. So I know from SOHCAHTOA that the sine is opposite over hypotenuse. So in this case, the sine of 25 degrees is equal to the opposite over the hypotenuse, which we're going to call d. So now I solve by multiplying both sides by d. Some stuff cancels out. You get 12,000. It's equal to d sine of 25 degrees. Then you divide, and you get the d is equal to the 12,000 divided by the sine of 25 degrees. So we just divided by this, right? So then I take out my calculator, and actually I end up using the Wolfram Alpha app. So when I do, I get 12,000 divided by, I get that d is approximately 28,394 feet. Okay, let's look at the next one. From the top of a 100-foot building, a man observes a car moving towards him. So we've got that situation in our mind. Let's see if we can't draw the picture. So I come over here, I get some more room, I hit paste. So I'm on top of a 100-foot building. So here, this is 100 feet, 100 feet, and he sees a car. So here's the car, and the car is going this way. So since it's coming towards him, later on, the car is going to be here, right? Because it's going this way. And here is the flat ground, right? Because the car is on the ground. So we've got our car, which moves from here to here. And so we also know that the angle of depression changes from 15 to 33. Remember, angle of depression is always from the horizontal. So we open down first 15 degrees, and then we open up a whopping 33 degrees. How far does the car travel? Notice what we've done. We've created two triangles. First, one that looks like this, where the angle, this green one, where the angle is 33 degrees. I drop down straight a right angle, and the height is 100 feet. That will give us this distance here, which is the same as this distance down here. And then we have another big triangle, which goes all the way out here to this one. It has a height of 100 feet, but then this angle for this big red triangle, this height again is 100 feet. That's feet. This angle is 15 degrees. So I think that's going to give us this big long distance here on top, which is same as this big long distance. So if we take the red and subtract the red distance and subtract this green distance, I think we'll find how far the car has traveled. So I'm going to call this distance 1, and I'm going to call this distance 2. Well, no, let's call the bigger one distance 1. So the big one I'm going to call distance 1, and the smaller one I'm going to call distance 2. So what we need to find is distance 1 minus distance 2 is going to give us what we need. So that's what we need to find. But we know that in terms of this angle, this is the opposite and this is the adjacent, right? So we know that the tangent 33 degrees is going to be opposite, which is 100, over adjacent, which is D2. And we also know that for this red triangle, we're going to have this as our opposite. So the tangent of 15 degrees is going to be the opposite, which is 100, over the adjacent, which is D sub 1. So now we have two things to solve. So let's bring those over here. So let's solve those two, shall we? First, I multiply both sides over here by D sub 2. They cancel out, and I get that 100 is equal to D sub 2 times the tangent of 33 degrees. That just means by dividing that I get D sub 2 is 100 divided by the tangent of 33. So in my trusty Wolfram Alpha calculator, I do 100 divided by the tangent of 33 degrees. Should be 100. I forgot to hit the 1, so now it's just 0. So it should be 100 divided by 33 degrees. That gives me that D2 is approximately 154 feet. Similarly, if I multiply both sides by D1, some stuff cancels out. I get D1 tan 15 is 100. In other words, 100 divided by tan 15 is what D sub 1 is. So if I divide now by the tangent of 15 degrees, I get that D1 is approximately 373 feet. So D1, 373, minus D2, 154, gives us 373 minus 154 quickly gives us 219 feet. That's how far the car has traveled. Cool. Determine two angles in radians, one positive, one negative, which are coterminal. Remember, when we do coterminal, we're doing plus or minus 2 pi because that's a wasted revolution, right? So we can come over here and take this plus 2 pi, and notice that 2 pi is the same as 2 pi over 1, but I want it to be the same denominator, so I hit this over here with a 7 over 7, so I really have negative 4 pi plus 14 pi. Plus 14 pi, doesn't give me any more room. Plus 14 pi. So 4 pi over 7 plus 14 pi over 7 is 10 pi over 7. So that's coterminal to the original. Or I could take my angle, and instead of adding, I could subtract a wasted revolution. Right? But we just said that's the same as 2 pi is the same as 14 pi over 7. So you're going to get negative 18 pi over 7 is something that is coterminal to the original. Okay. Now we want to do complements and supplements. When you're thinking about complements, you are going to take pi over 2 and subtract your angle. And when you have a supplement, it's going to be pi minus your angle. And if you get a negative, something's weird and you don't get an answer. So For the complement of this question, we're going to have pi over 2 minus pi over 12. But the only way to do that is to get a common denominator. So we hit this with 6 over 6. This is 6 pi over 12 minus a pi over 12, and your answer is 5 pi over 12 would be the complement of my original angle, pi over 12. Then if I want to do the supplement, I take pi minus my angle, but again, I need common denominators. So since it's over 12, I hit this with a 12 over 12, and I would get 12 pi over 12 minus 1 pi over 12. It turns out that 11 pi over 12 is going to be the supplement of my original angle. Let's do it again. If you want the complement, you do pi over 2 minus your angle. So you do pi over 2 minus 2 pi over 5. So I think the least common multiple of these is going to be 10. So I'm going to hit this with 2 over 2 to get a 4 pi over 10. And hit this with 5 over 5 to get 5 pi over 10. So when you subtract, you're going to get 1 pi over 10 is going to be the complement. Now the supplement, you're going to take pi minus an angle. And so this is going to be pi minus 2 pi over 5. So I hit this with a 5 over 5 so we can have common denominators. And 5 pi over 5 minus 2 pi over 5 is 3 pi over 5. Right? Questions? Hope you don't. If you do, let me know. Okay, I'm going to keep on going, probably about 10 more minutes until I have my next class. So, sine of 240. Well, I draw my picture. If you stop here, that's 180. If you go just a little bit more, you would go 60 more to get to 240. That means if you want to know the sine, that's the y-coordinate. But I want to know where I have a theta reference angle equal to 60 degrees. What the sine is, well, we know on trig hand from 60 degrees that sine is the square root of 3 over 2. So that means that down here, the sine is going to be negative square root of 3 over 2 because sine is y. If I do the sine of 30 degrees, that's the same thing as sine of pi over 6, and so that's going to be 1/2. So over here, tangent of 5 pi over 2. Tangent is sine over cosine. 5 pi over 2. 5 pi over 2. On the unit circle, here is what? 2 pi over 2. Here is 4 pi over 2. And if I go one more pi over 2, I'm sitting right here at the top of the unit circle where my cosine is 0 and my sine is 1. So this is 1 divided by 0, which is undefined, right? So this is undefined. Makes no sense. Cosine 11 pi over 6. If I stop here, that's 6 pi over 6. Go all the way around, that's 12 pi over 6. So I must have stopped short 1 pi over 6. But I want the cosine up here, a reference angle of pi over 6, and it's going to have the same 1. In other words, this is equal to the cosine of pi over 6, but that's the same as cosine of 30 degrees, so I'm going to get the square root of 3 over 2. Okay. Tangent of 210. Let me give myself some room. Tangent of 210. Well, tangent, again, is sine over cosine. 210, right? So if I go 180, I would need to go 30 more, right? So here, that means to get to 210, I'd need to go 30 more. So my theta reference angle is 30 degrees. So for 30 degrees, the cosine is a square root of 3 over 2, and the sine is 1/2. So down here, the cosine would be negative square root of 3 over 2, and the sine would be a negative 1/2. So if you take a negative 1/2 divided by negative square root of 3 over 2, you're going to flip and get the square root of 3. Because when you divide, you multiply by the inverse. Okay. All right, keep on going. Cosine of 1/2. 1/2 is up here on the unit circle, pi over 2. And cosine is x. So since the x coordinate is 0, then this is 0. All right. Tangent of 13 pi over 4. Well, again, this is going to be the sine of 13 pi over 4 and the cosine of 13 pi over 4. Let's see. If I wanted to, I could take out any wasted revolutions. That's one way to do it, right? So I know that in terms of 4, 8 pi over 4 is a wasted revolution. So if I take out my wasted 8 pi over 4, this is the same as the tangent of 5 pi over 4. You're going to get the same thing and be on the same place on the unit circle. So this is 4 pi over 4. If I go one more, I'm now down here with a reference angle of pi over 4. So I need to come over here with a theta reference of pi over 4. Know that in terms of cosine and sine, I get the square root of 2 over 2. Square root of 2 over 2. Down here, it's going to be negative, both of those, right? But if you take sine divided by cosine, I think it's pretty clear you're just going to get 1. Tangent of 4 pi over 3. So here, if we stop, that's going to be 3 pi over 3, also known as pi. So I have to go one more pi over 3 to get out here to 4 pi over 3 for this dot on the unit circle. So you're going to go back this way, and you have a theta reference of pi over 3. Well, for pi over 3, the cosine is 1/2, and the sine is the square root of 3 over 2. So if tangent is just equal to the sine divided by the cosine of 4 pi over 3, then what you're going to get down here, the cosine is going to be a positive 1/2. I'm sorry, a negative 1/2. And sine is going to be a negative square root of 3 over 2. So it's going to be negative square root of 3 over 2 divided by negative 1/2. It's going to flip and give you a positive square root of 3. I thought we had one like that earlier. Is that just our similar to it? Okay. Is everybody okay? All right. Let's go over here. Sine of 5 pi over 4. This would be 4 pi over 4. If I go another one, I'm now down here at 5 pi over 4. It has a reference angle, pi over 4, but the cosine and the sine for pi over 4 are root 2 over 2. Back here, the cosine and the sine are negative root 2 over 2 and negative root 2 over 2 because cosine is x and sine is y. So the sine is negative root 2 over 2. Cosine 5 pi over 3, this is 3 pi over 3, and I need to go 1, 2. 2 pi over 3 is going to put me in this quadrant, right? So it's going to be some positive number. If I want to get all the way to 6 pi over 3, or 2 pi, I need to go one more pi over 3. So that means that my reference angle right here is pi over 3, but my cosine and sine of pi over 3 are 1/2 and the square root of 3 over 2. So this is going to be the exact same x value. So you're going to get 1/2. Tangent of negative 5 pi over 6. If you open up negative, then that means you go backwards. So this would be negative 6 pi over 6. So I have to stop short 1 pi over 6. That would be negative 5 pi over 6 would be here. So now I need to use a reference angle of pi over 6. And for pi over 6, the cosine is the square root of 3 over 2, and the sine is 1/2. Now, tangent is sine over cosine. Remember, it's the sine of this angle divided by the cosine of this angle. And so if we're over here for cosine and sine, our cosine is going to be negative root 3 over 2. Sine is going to be negative 1/2. So it's going to be negative 1/2 divided by negative square root of 3 over 2. So we're going to take this and multiply by the reciprocal. So you end up getting 1 over root 3, which, yes, if you'd like to simplify, is root 3 over 3. Okay, cosine. Cosine is just x. So here is pi. Here's 2 pi. The x coordinate here is 1. So this is 1. And that is a perfect place to stop. I'll do some more in a bit.